All right, so now we're getting into word problems. Before we can actually do any word problems, let's talk about some vocabulary we need to know, some definitions. So the first new definition we're going to talk about is an angle of elevation. So they're saying if an observer at a point P looks upward towards an object at A, the angle the line of sight PA makes with the horizontal PH is called the angle of elevation. All right, well, that's just the formal definition. Let's just make it make sense to you. Generally speaking, if you're elevating, are you up or are you down? Up, right? If you're elevating, generally that word means up, right? So the angle of elevation is an angle that is looking up. So right here, we know an angle is made with two sides, right? So an angle of elevation has to be an angle that where one ray is looking up, but the other ray has to be horizontal. That is an angle of elevation. One ray looking up, the other ray has to be horizontal. All right, well, let's talk about angle of depression. Generally speaking, if you're feeling depressed, are you feeling up or are you feeling down? You're feeling down, right? So an angle of depression will be an angle that is looking down. But this is a really big misconception and it messes everybody up on the word problems. So do you all see the diagram that I have here over to the right? So they'll say, okay, well, I know I need an angle and I need one of the sides going down. And everyone's really good with that. But then what they do is they choose the other vertical side to make the angle and they'll say this is the angle of depression. No, an angle of depression, similar to an angle of elevation, one of the sides has to be horizontal. Always. There's no exception there. So an angle of depression is one side of the angle looking down and the other side going across horizontally. That is our angle of depression.
So you would take the bigger angle and subtract it by the smaller one?
No, there's no subtraction. I will say you, oh, this angle of elevation is like 10 degrees or whatever it is, or angle of depression is, you know, whatever degrees. So we don't
take some extra steps to get there.
I'm not going to make it that complicated. But yeah. So let's say, you know, I see what you're saying. Let's say I gave you this angle is like 20. We would end up making a rectangle right here and you'd be like, oh, this has to be 70. Is that what you mean?
Yeah.
Yeah, that would work. Yep, absolutely. And I like the way you were thinking there.
So is the angle of like elevation usually the right angle?
Never the right angle. Angle of elevation is one of the acute angles, one ray looking up, one ray going across. Right? This is just, this one's not looking up or down. This is just a perfectly straight right angle, 90 degrees. Okay, so now what we're going to do before we do any word problems, let's identify in the diagram our angle of elevation and our angle of depression. Can somebody name me the angle of elevation using 3 letters here for number 1?
CAB.
Good. CAB or BAC is my angle of elevation. So it's basically this person. He's looking up at the top of the building. So angle BAC or CAB, it's the same angle. All right, can somebody different name me the angle of depression? Sion.
Angle DCA.
Good, angle DCA. What's happening in angle DCA? Somebody from this window is looking down at the person on the street. That's what's happening there. Somebody from that window is looking down at the person on the street. All right, number 2. Can somebody name me the angle of elevation in number 2? Sam. QS. Excellent. Angle QSP or PSQ is our angle of elevation. What's happening there? There's some person looking up at the plane, and that is our angle of elevation made with the horizontal. Can somebody tell me the angle of depression using 3 letters for this problem, number 2? Somebody new. Oscar.
RQS.
You got it. Angle RQS is our angle of depression. What's going on here? Somebody from the plane is looking down at the person. That is our angle of depression. All right, number 3. Can somebody tell me the angle of elevation with number 3? The angle of elevation in number 3. Julia. Good. NPM is our angle of elevation. Somebody in the car is looking up at the hot air balloon. So, you got it. LMP is our angle of depression. Somebody in the hot air balloon looking down at the car. All right, now number 4 is a little bit different. This is pretty cool because we have an angle of elevation and an angle of depression, but they're being used with the same horizontal line, which is absolutely okay. Our angle of elevation is the statue looking up at the plane. That's our angle of elevation. So our angle of elevation here is angle CBA. What is our angle of depression? What's our angle of depression, Vin? CBD. What's happening? So the statue for the angle of elevation is looking up at the plane, and the angle of depression, the statue is looking down at the, at the ship. And is it okay that an angle of elevation have the same horizontal line?
Yeah.
Absolutely. We're actually going to do word problems like that, where we share the same horizontal line.
But the horizontal line will always stay horizontal.
Yep. Okay. All right. Let's do some word problems. All right. Number 1, a ladder leaning against the side of a house forms a 65-degree angle with the ground. The foot of the ladder is 8 feet from the house. Find the length of the ladder to the nearest foot. All right, half the battle here, or honestly, I'm going to say like 80% of the battle here is just creating and labeling the diagram correctly. Once you do that, it should all be fairly simple after that. So it says a ladder leaning against the side of a house. All right, so we got to draw that. A ladder leaning against the side of the house. I would not be elaborate with my drawings. So here's my house. Here's the ground. Now, if I'm going to lean a ladder against the house, do I lean it vertical or do I lean it sort of on a slant, a diagonal? We lean it on a diagonal. So here is my ladder. All right, read it again. A ladder leaning against the side of a house forms a 65-degree angle with the ground. All right, guys, this is my ladder. Where is the ground? On the bottom. So where is my ladder making an angle with the ground? On the bottom. So when it says it creates a 65-degree angle with the ground, this is 65 degrees. Does everyone understand why I put the 65 on the bottom there? All right, what kind of angle is the house making with the ground, we hope, if it's structurally safe? A 90-degree angle, right? All right, so here's some more wording. The foot of the ladder is 8 feet from the house. Guys, where are your feet on your body? Are they on the top of your body or the bottom of your body? Bottom. When they're saying the foot of the ladder, are they talking about the top of the ladder or the bottom of the ladder? The bottom. So they're saying the bottom of the ladder, right here, the foot of the ladder is 8 feet from the house. Well, here's our house. So see this pink segment right here? That is 8 feet. We're not going to do the nearest foot. Everything is going to be the nearest tenth. Why is that? Why am I doing everything the nearest tenth? Because it will be the nearest tenth on the test. So it says find the length of the ladder. Do we all agree that blue segment is our ladder? So that's what I'm going to go ahead and call X. So now we're going to use trigonometry. Everything's in reference to which angle, do you think? the 65-degree angle. So I'm going back to SOHCAHTOA. And I'm going to look at which sides I was given. I was given the 8, which is adjacent to 65. And I want to find x, which is the hypotenuse. Do we all agree? So according to SOHCAHTOA, which trig function pairs the adjacent and the hypotenuse? Maya. Good. So we're going to write cosine what? We can never let it stand alone. Cosine 65 equals 8 over x. So now this brings us back to what we were doing last class, right? I can't solve for a variable in the denominator, so what must I do? Multiply x on both sides. So that cancels. So now we're going to have x times the cosine of 65 equals 8. What should I do now? Good, Sam. Divide cosine 65. What is it? 18.9. Do we have feet? Oh, you're probably in degrees. I mean radians. Are you in radians or are you in degrees?
I'm not sure.
Yeah, you're in probably radians. Let me fix that for you. Yep, you're in radians. There you go. So now you should always be in degrees. Try to measure.
Wait, how did you get there?
So go to mode. And see, right here, it was highlighted black on radians, and I moved it over to degree.
Oh, I see.
You'll use radians in calculus. Okay. Everybody able to get the 18.9 on their calculator? We're good? Okay. Number 2. We're saying Patricia is sitting on a pier. Sam. Patricia is sitting on a pier. She has just tied her canoe to a hook at the end of the pier. If the pier stands 29 feet above sea level and the rope is 52 feet long, what is the measure of the angle formed by the rope and the pier? Round to the nearest tenth, not degree. We're going to round everything to the nearest tenth today. Round to the nearest tenth. All right, let's get our diagram going. Patricia's sitting on a pier. I don't care about that. She just tied her canoe to a hook at the end of the pier. I do care about that. So what do I have right now? I have my water. I have my pier. There's my pier. And now I have a canoe tied, there's my canoe, to the end of the pier. Do we all agree with this diagram so far? If the pier stands 29 feet above sea level, what is that telling us? The height of the pier is 29. Do we also agree the pier should be making a right angle with the water? And the rope is 52 feet long. Where should I label that 52? Good. The hypotenuse should be 52. What is the measure of the angle formed by the rope and the pier? You guys tell me, is that angle 1 or angle 2 they're talking about? Find the angle formed by the rope and the pier. Which angle is that? 1 or 2? Oscar. 1. So aren't they saying find that angle? They're asking us to find that angle. What do I call an angle I don't know? Theta. Theta. Remember the circle with the loop through it? So we are trying to find theta. Since I'm trying to find an angle, that's when we're inverse sine. Remember that? Sine to the negative first power? Inverse sine, that's when we use that. But before we can use sine to the negative first power, the inverse of sine, we need to figure out our equation. So everything is in reference to theta. Do we all agree 29 is adjacent and 52 is the hypotenuse? So are we so, ka, or toa? Ka, what does ka stand for? Cosine. And now how do I write it? Cosine what? Theta. Good, Vincent. Cosine theta to always the angle with the cosine, sine, or tangent. So cosine theta equals the adjacent, which is 29, over the hypotenuse, which is 52. Now, remember, I have to solve for just theta. Can I ever divide cosine without an angle? I can't divide cosine without an angle, so that's when we have to just cancel the cosine. So what do I do to just cancel the cosine? The inverse of cosine. The inverse of cosine. So that cosines cancel, so I'm left with theta equals the inverse of cosine of 29 over 52. So in your calculators, how do I get the inverse of cosine? Who remembers? How do we get the inverse of cosine on the calculator? Oscar?
Cosine, second cosine.
You got it. Press second cosine. Then you're going to type in 29 division sign 52, and you get 56.1 degrees. All right, number 3, its wording is really sneaky. Number 3, the wording is really sneaky, but these types of sum questions come up often. These types of sum questions come up often. So here they're saying when the angle of elevation of the sun is 52 degrees, a tree casts a shadow of 25 feet. Find the height of the tree to the nearest foot. So a lot of students don't draw this. They're like, okay, angle of elevation of the sun. So I'm going to the sun and I'm going to draw an angle of elevation from the sun. No, that's not what that means. It doesn't mean we're drawing an angle of elevation out of the sun. What does it mean when it says the angle of elevation of the sun? Well, we know the sun is obviously very high, and the sun's rays come down. Remember, we had spoken about this, that their rays are virtually parallel, right? When they're talking about the angle of elevation of the sun, they're talking about the sun's rays hitting the ground. They're talking about the sun's rays hitting the ground and going back up to the sun. So when they're saying the angle of elevation of the sun, we're talking about the angle of elevation of the sun's rays going back to the sun. So this is the angle of elevation of the sun. Right? I would know how to do something like this. All right, a tree casts a shadow of 25 feet. So what I'm going to do, there's my sun, here's my tree. Where's the shadow now if that's my tree? So I'm making this work for me. I'm making it make a right angle, a right triangle. Where do you think the shadow is going to be if that's my tree? Where? Not the hypotenuse, right? Like if I'm standing, my shadow is not coming from my head, like making a hypotenuse. That'd be crazy, right? Where's my shadow? On the ground, right? Isn't the shadow always on the ground? So when it's saying a tree casts a 25-foot shadow, this is 25 feet. Find the height of the tree. So I'm going to call the tree X. Maya?
How do I know where the tree goes?
So you're going to do it strategically to make a right triangle. So we knew they said the angle of elevation of the sun. So we needed the angle of elevation looking up at the sun. So I needed that tree to just close up that triangle for me so we can do this. So it's all about just making right triangles ultimately. All right, everything's in reference to the 52. Do we agree the 25 is adjacent and the x is opposite? So which trig function are we using? So TOA, which one is it? Tangent, you got it. It is TOA. So how do I write this? Tan what? Good. Tan 52 equals opposite, which is x, over adjacent, which is 25. Who remembers how to solve this? What should I do? Sam? You got it. We're going to multiply 25 on both sides. So x will equal 25 times the tangent of 52. And can somebody tell me, not to the nearest foot, we're nearest tenth, everything's nearest tenth. Can somebody tell me what that is? 52.0? Oh, 32.0 feet. Is it important? Sam said 0.0. Is it important that we write down that 0.0? Yeah, I would have to take a point off if you didn't. Why? Because I said to round to the nearest tenth, so you have to show me the 10th spot, even if it's 0. Okay. Let's keep going. All right, so now we're going to get into problems that are a little bit more complicated. We ready? So those were like our basic ones. Now we're stepping it up. All right, a surveyor is 100 meters from a monument. The angle of elevation to the top of the monument is 41 degrees. The surveyor's instrument is 1.5 meters above the ground. Find the height of the monument to the nearest tenth. All right, we got a bunch of things going on. A surveyor is 100 meters from the monument. I'm going to read it through one more time. A surveyor is 100 meters from a monument. The angle of elevation to the top of the monument is 41 degrees. Don't draw this, but Oscar, do you have a question? Sure. All right, generally speaking, if I just read this first sentence, it says the angle of elevation to the top of the monument is 41 degrees. Here's my monument, and I would just say angle of elevation to the top of the monument is 41 degrees. So I would draw one ray looking up at the monument and one ray horizontal. That's what I would normally do. But don't draw this because that's wrong. Why is that wrong? Because now it's saying the surveyor's instrument is 1.5 meters above the ground. So now, Jen, I would normally just make the surveyor some dot on the ground. He's not worth being more than a dot on the ground. But now they're giving the surveyor height. Why? How do I know they're giving the surveyor height? They're now saying the surveyor's instrument is 1.5 meters above the ground. So now I have to take that into consideration. So not only do I just have a person looking up at a monument, but now they're saying, okay, well, here's my ground. All right, I have an instrument that's 1.5 meters above the ground, and then I have my person looking out of it, right? So because they gave that person height, I couldn't just make him a dot on the ground. Normally, if they don't give that person height, you just make them a dot on the ground. It doesn't matter. All right, now there's more going on. What is this person looking at? He's looking at a monument. Here's my monument. So what are we doing? It says the angle of elevation to the top of a monument. So an angle of elevation is coming from the surveyor's instrument. It's one ray looking up and the other ray what? The other ray has to be horizontal. Good, Livy. The other ray has to be horizontal. So do we agree this angle right here is 41 degrees? Is everyone okay so far? Okay. Now, when the horizontal meets the vertical monument, do we agree we're getting right angles over here? All right. We didn't label something. What did we not label? A surveyor is 100 meters from a monument. Max? You got it. When it says a surveyor is 100 meters from the monument, you're choosing the closest distance. The closest distance is just, in this scenario, just directly across. They're not saying 100 meters from the top of the monument. They're saying 100 meters from the monument, so it's the closest one directly across. That is the 100 meters. Now, I think you all see this, or I hope you all see this. Do you see this right triangle? So we ultimately want to find the height of the monument. So we can use the right triangle and find x here. But when I find x, is that the height of the monument? No, the height of the monument is this whole thing is the height. So what would I have to do?
Add 1.5.
You got it. do you all see we have a right triangle on top? And then don't we have a full four-sided figure on the bottom? That four-sided figure on the bottom is a rectangle. So if the left is 1.5, the right is also 1.5. All right, so now we need to find x, and then once we find x, I can add 1.5 to it, and that will be our total answer. So according to SOHCAHTOA, we know everything's in reference to 41. X is opposite, 100 is adjacent. I am using tangent. Tan 41 equals x over 100. Try not to get ahead of me here because I'm going to say something in a minute that's very important. Do we all agree we need to multiply by 100 on both sides? All right, so here we're going to have 100 times the tangent of 41 equals x. Now, my final answer said round to the nearest tenth. If you round to the nearest tenth right now, in some problems that might be too early, and then your whole answer at the end will be 1/10 off. So when this is not your final answer, you need to go at least 1 or 2 decimal points beyond what they're asking. So if I'm asking to do the nearest tenth, I have to go to the 100th or the 1000th place just to be safe until my final answer. So when I do 100 times the tangent of 41, okay, so we would get x is equal to 86.92. You guys might just want to leave it 86.9. No, you can't. We're going to do 86.92, and I'm going to just make it a 9. I'm going to do to the 1000th. I rounded to the nearest 1000th. Yeah.
Or we can just use the answer function.
Yep, absolutely.
Like answer plus.
Yep.
Because what it does, it takes your
Yes.
most recent answer.
You could absolutely do that. Okay, so this is not my total answer. What are we going to do now? We're going to say the height is going to be 86.929 plus 1.5. Now, since this is my final answer, now can I round to the nearest tenth? Absolutely. So we're going to do plus 1.5. And now rounding to the nearest tenth, what are we at? 88.4 meters.
Why couldn't you just do when you get your answer, which was like 86
Plus 1.5?
Yeah.
Yep, that's what Simon said. You absolutely can do that. Some people don't like to. They like to just write it out. So that's what I was saying. But you could absolutely do that. And Simon had said the same thing. No. All right. Next one. It says April is in a plane that is at an elevation of 500 feet. She spots a person sunbathing on the roof of a 225-foot building. The distance from the plane to the person is 360 feet. Find the angle of depression to the sunbather. Round to the nearest degree. Are we ready to create this diagram together? So it says April is in a plane that is at an elevation of 500 feet. I'm going to draw that. All right, so here's our plane. And when it says it's at an elevation of 500 feet, what does that mean? It's 500 feet from where? The ground. So then here's my ground. And I know the plane to the ground is 500. Are we all good so far? All right, let's keep going. She spots a person sunbathing on the roof of a 225-foot building. So now I'm going to have my building. And how tall is this building? 225. And the person sunbathing is just a dot. There's our person sunbathing. The distance from the plane to the person is 360 feet. Whenever they're talking about distance, they're talking about the shortest distance. In this scenario, here is April in her plane. All right, the shortest distance between April and the sunbather is going to be a direct segment. Do we agree? The shortest distance between April and the sunbather will be a direct segment. So they're saying this is 360. Everyone's still good so far. All right, let's keep going. They said find the angle of depression to the sunbather. Well, do we agree the angle of depression is going to come from April on the plane to the sunbather? A lot of students want to call this theta. No, that's not the angle of depression. Remember, by definition, an angle of depression is one ray looking down, but what does the other side of the angle have to be? A horizontal. So now what do I have to do? Create a horizontal. And now that's theta. That's my angle of depression looking at the sunbather. What do you think I'm going to do with this empty space right here? Any ideas what I'm going to do?
Close it.
I'm going to close it up. Why am I going to close up this empty space? To create a rectangle, and also what's on top of that rectangle? A right triangle. Do you all see that? So we have a big rectangle, but then don't I also have a big triangle? Now, I love that Libby said this big shape is a rectangle. She's absolutely right. And in a rectangle, aren't opposite sides congruent? So if the left side is 500, this right side is also 500. What does that mean for this height of the right triangle? What does that mean? How long is that? Good, Max. How'd you get 275? Good. Yeah, we did 500 minus 225, and we get 275. Now I can use this triangle. We know 275 is opposite. 360 is the hypotenuse. Which trig function are we using? Sine, cosine, or tangent? Sine. How do I write it? Sine what? Theta. Sine theta equals 275 over 360. Sam, since I'm solving for theta, what do I have to do since I'm solving for an angle? Second sine. That's when we do to the negative first power, right? So we're going to do theta equals the inverse of sine of 275 divided by 360. We're not rounding to the nearest degree. Round to the nearest tenth, please. What was it? 40.2 degrees. No? Did something go wrong? Let me see. Second sine. So you should do second sine 275 divided by 360. And it should be 49.8 degrees. I changed the whole thing to the nearest tenth. Now you're good. All right, next one. Greg is standing on a dock looking at a ship that is 50 feet away. Oh no, I'm not going to have enough time to finish, am I? All right, we need to do this problem because there's something similar to it on your test. Can somebody remind me tomorrow? Okay. We'll stop here.